proving proportionality theorem, there are three things that you must know in proving this theorem. The first one is the fact that in triangle PQR, I'm going to draw triangle PQR so that we demonstrate this. There's triangle PQR. In this triangle, you must remember that the height is defined relative to the base. The height of a triangle is always perpendicular to the base, and it is drawn from a vertex. That is very important. Now I'm going to draw height K, which is perpendicular to PQ. There's height K perpendicular to PQ. Then I'm going to draw height H from the vertex Q, which is perpendicular to the base PR. This is height H. Now, what you need to know is the area of triangle PQR would be half base multiplied by perpendicular height. This is very important. Area of triangle PQR is half base multiplied by perpendicular height. Remember that the height is defined relative to the base. The height is defined relative to the base there. Meaning that the area of this triangle can be defined as half PQ, which is the base. Now, if I'm using PQ as the base, the height would be small k, because the height is defined relative to the base. I can also say area of this triangle PQR is half. I have the base PR multiplied by the perpendicular height, in this case, would be H. Now, the knowledge that you need to take from this is the fact that the area of this triangle, irrespective of the height, does not change. It remains the same. What I'm saying now is area of triangle PQR will always be area of triangle PQR, because we have the common triangle. Now, in this case, I have half base PQ multiplied by K, which is equals to half base PR, which is multiplied by H. Now, why is this the case? We are talking about area of triangle PQR, but measuring the height from different vertices. I have measured the height from vertex Q relative to base PR. I have measured the height from vertex R relative to the base PQ. The area of the triangle does not change. That is basic knowledge number one. Now let's go to basic knowledge number two. This is very, very important in the proof of the theorem. Basic knowledge number two. What you need to know from the previous grade is the fact that, number one, when lines are parallel, I'm talking about two lines which are parallel here, they maintain the same height between them throughout. If you measure the distance from this line to this line at this point, and everywhere throughout these lines, it would be the same. Parallel lines maintain the same height between them, they slope towards the same direction. Now, what if I draw two triangles here? There's triangle PQR, I'm going to have there PQR. Then again, I come and draw another triangle. I draw triangle SQR. Now, because they are between parallel lines, the two triangles will have the same height. Triangle PQR will have the same height as triangle QSR. The reason is they are between parallel lines. Now, again, if you look at something, triangle PQR and triangle SQR. If you look at these two triangles, they have QR and QR. Now, QR and QR, I am talking about this side. That means this side is common to both triangles. Again, if you can look at triangle QPS and triangle RPS, those two triangles will have the common side, which is PS. Now, having the common side, which is PS, and the others having the common side, which is QR, and having the same height, that tells us that these two triangles, which are between parallel lines, will have the same area. Let's look at this. Area of triangle PQR will be equals to half. If I take the base, triangle PQR, and I take the base to be QR, it would be half QR multiplied by perpendicular height. Now, if you again look at another triangle here, which we talked about, SQR, its area would be half the base, QR again, multiplied by perpendicular height. What is very important is the fact that we should remember that in this case, perpendicular height here and perpendicular height there is the same thing because they are between parallel lines. And if you look at this, we have QR and we have QR, meaning that these two triangles will have the same area. What is the reason? The reason is the fact that they are between parallel lines which maintain the same height and they have the common base. That was basic knowledge number 2. Now we move to basic knowledge number 3, which is also very important. Basic knowledge number 3 let's have a triangle. There's our triangle. There's the triangle there. Now in this triangle, I'm going to draw the height relative to the base. It would be perpendicular to this. Let's take it as P, Q, R again. Now, we have the height H, triangle PQR with the height H here. Then from this, I am going to draw from this vertex another triangle again. I draw a line obliquely to QR. Now I put point S there. If you look at this now, from that particular vertex, I have drawn another triangle. We had triangle PQR, which had the height perpendicular to base QR. But from the very same vertex, that is very important, same vertex P, we have drawn another triangle, which is triangle PQS. If you look at this now, we have two triangles with the same height, and those two triangles happen to be sharing a common vertex. Should be very careful about this. Area of triangle PQS will be equals to half base. Area of triangle PQS, the base will be QS because the height is H and it is perpendicular to this line. The base is QS multiplied by the height, which is H. I'm taking area of triangle PQR, the bigger triangle now, PQR. Area of that triangle would be half base because the height is that one, it is perpendicular to this side. The base would be QR multiplied by H. You look at this now. We have two triangles, PQS and triangle PQR, with a common height. But now the base here is QS and the base there is QR. What is very important, we have common height with common vertex. Now, with this knowledge, I can proceed to prove the theorem that states that a line drawn parallel to one side of the triangle divides the other two sides in the same proportion. Let's prove this theorem. Very important, I want to stress the fact that the three basic knowledge that we had here will appear as we prove the theorem. Now I am proving the theorem. I'm going to start by constructing. Construction. Why do we construct? We construct so that we can have previous theorems helping us to prove the new theorem. Construction. I'm going to say join B to E and C to D. That is very important. I'm joining the 2 points B and E There we go. Take my ruler. I draw that line. I have joined that. Let's look at what we have done now. We have triangle EDB with triangle EAB. The two triangles are sharing their common vertex. That was basic knowledge number 3. Two triangles sharing their common vertex. Now I'm going to join C to D. Put my ruler beautifully there. I join C to D. Again, if you look at this, common or basic knowledge number 3, I have triangle ADC with triangle EDC sharing the common vertex. I can boldly say common vertex there, basic knowledge number 3. Moving on from this now, I am going to construct further construction, all right? Further construction and draw height H and height K in triangle ADE. Let's remove that there. I'm going to draw the height H and the height K in triangle ADE. Here's triangle ADE. Now let's draw those heights. I'm gonna draw them using dotted lines. Let's start with that one. It is from the vertex E. It is perpendicular to the base AD. Let's call this one K. Then let's have another height again according to our construction. That is going to be height H. It is from the vertex D, perpendicular to line AE. Now we call this one small h. I want to stress this point again. We have common vertex for triangle ADC. We have common vertex for triangle AEB. That was basic knowledge number 3 here. Now I'm about to prove the theorem. If you look at this, basic knowledge number 1 appears at the top. Basic knowledge number 2 appears at the bottom. Triangles between parallel lines. Basic knowledge number 3 appears both at the top and the bottom. Common point, common vertex, same height, common vertex, same height. Those are very important. Now I am proving the theorem. I'm going to start by saying area of triangle ADE is equals to, I'm taking the area of this triangle, it will be equals to half base. Look at what you want there. You want AD. Start by taking the base as AD. It will be half AD multiplied by, very important, when AD is the height, when AD, is the base, the height would be the line which is perpendicular to the base, because the base is defined relative to the height. It will be K there. Again, in the same triangle ADE, I'm going to take the area of this triangle looking at the different base and height now. Height H will be perpendicular to AE, and there is AE there. That means I'm going to have half AE multiplied by the height is now small h. And what do I know about the area of triangle ADE? Both areas, this area and this area, will be equal. Area of triangle ADE will be equals to area of triangle ADE. What is the reason behind that? We have common triangle. The triangle is the same. We are taking the area using different heights. Therefore, now I can say half AD multiplied by H. Sorry about that. Half AD multiplied by K is exactly the same as half AE multiplied by H. We have said that the reason is the fact that the two triangles are common, which is true. Now we move to the second part. We need to have DB. I look at this, I have DB there. Now, which triangle am I going to use to have DB? I'm going to take area of triangle. Let's look at this now. DB, the height must be perpendicular to this side as a base. That means I am going to use that height. I'm taking area of triangle BED, which is equals to half DB multiplied by the height, which is small k. Looking on the other side, I need to have EC. Don't forget the fact that point D and E are common vertex to two triangles. I am now taking the area of triangle because I want EC. I'm going to take the area of triangle CDE. Let's take that area of triangle CDE, which is going to be equals to half base. The base is what we are looking for, EC, multiplied by, if the base is EC, that means our height must be perpendicular to EC. And in this case, EC is produced to A. That side is perpendicular. That means this would be H. Now, let's look at the two triangles. If you look at the two triangles, I can rightfully say triangle, area of triangle BED will be exactly the same as area of triangle CED. Now, I want us to revisit that. Area of triangle BED, here is BED. I'm saying it is equals to area of triangle CED mathematical, equals to area of triangle CED. Let's look at these two triangles. If you look at them, they are between parallel lines. Parallel lines maintain the same height. And again, if you look at them, you can see that they both share the base or the common side ED. Now, we said that if triangles are between parallel lines and sharing a common base, because the height is the same throughout here, the areas of those triangles would be equal. I need to give my reason here, and my reason is same base between DE parallel to BC. This is very, very important. Now, in conclusion of this, can you see that this triangle ADE with different heights was the same, or it was having the same area? Now I can say area of triangle ADE there divided by area of triangle. I'm taking the top, I'm going to divide it by bottom. I have taken area of triangle ADE, which is equals to half AD, I start by AD first, multiplied by small k. I divide it by area of triangle BED, which is equals to half DB multiplied by, remember, area of triangle DBE was somewhere BED, it is there. The height was K. It is K. Now, mathematically speaking, half will cancel half, K will cancel K, meaning that AD divided by DB is the quotient of the areas of these two triangles. Now, I'm going to take area of triangle ADE and I'm going to divide by area of triangle CED. Let's see what we get. Area of triangle ADE, remember we have used that one, we are now going to use this one. It would be half multiplied by the base AE, and when the base is AE, the height is H. Then we come to this one. Area of triangle CED is equals to half base, which is EC multiplied by H. Mathematically speaking, this cancels that, this cancels that, and the quotient of the two areas is AE divided by EC. Now let's look at this. I divided this area, which is equals to this area, by this area, which is equals to that area. I want to repeat this again. I divided the area of triangle ADE, which is the same as triangle area of triangle ADE, taking it from here. I divided it by the area of triangle BED, which is the same as area of triangle CED. That was taken from there. That means now that the answers that I would get, they would be exactly the same. In this case, I can say, therefore, AD divided by DB is exactly the same as AE divided by EC. We have actually proved the theorem that says a line drawn parallel to one side of the triangle divides the two other sides in the same proportion. What I want to drive home is the fact that the basic knowledge that I gave you are very important. Basic knowledge number one is applicable on the top part of the triangle, and basic knowledge number two is applicable at the bottom part of the triangle. Now the last basic knowledge, common point and same height, common vertex, same height, is applicable at the bottom and the top. Again here, bottom and the top. That is how you should remember this theorem. Thank you.